So kiddos, again today, Pythagorean theorem. Again, it's one of those building blocks in geometry. Pythagorean theorem is very useful. It's one of the things that students walk away from geometry remembering because it's one of those formulas that's super simple. Okay, super simple. You probably already know it and you don't even know why you know it. So couple reminders for our lesson today. Pythagorean theorem is specifically used for right triangles. Okay, so we have to talk about some angle measures. A right angle, again, is one that measures exactly 90 degrees. Okay. Now, there's two ways that you can tell a right angle is a right angle. Of course, the first way is if you see that it actually is marked 90 degrees, but that's not very common. The more common way that you can tell something is a right angle is because the little box that's in the corner that we use as a visual cue, and this tells the person looking at it that this is a right angle. So without it saying 90 degrees already, you know that this little box in the corner means it's 90 degrees. What's up?
Not gonna lie, just by looking at the lines, like the arrows,
you can definitely tell sometimes, but you got to be careful because in geometry, sometimes they like to trick us and it might be 89 degrees or 91 degrees, right? So you don't ever want to assume based on the picture. So if you don't see this little square here, we can't just say, oh, it looks like a right angle, so it must be one. We always got to look for this little visual cue, okay? So right angle is very important because, again, Pythagorean theorem only works for right triangles, okay? Now, square root, we've done these before, but we do have to review it, make sure we understand. So the square root is the opposite of something squared, like how adding is the opposite of subtracting, how multiplying is the opposite of dividing, right? If we want to get rid of a square, we have to use a square root. So like, for example, you see right here, the square root of 25 is 5 because 5 squared is 25. So it gets rid of the square and you only have the 5 left. Or the square root of x squared, the square root cancels out with the square and the only thing left over is x, okay? That arrow just like disappeared. There we go, okay? So that's what a square root does. If we ever need to get rid of the square symbol, we use a square root and it gets rid of that exponent, okay? Just another inverse operation. Cool beans? Any questions about that? Okay, you'll see it in action today. So even if you don't really understand just in the context of what we have right here in the notes, you'll definitely be able to see it in action in our lecture today. Okay, so we're going to jump into it. Right triangles and Pythagorean theorem. So if we know that a right angle is any angle that measures exactly 90 degrees, a right triangle is a triangle that has a right angle. So you can clearly see, like Roberto said earlier, you can see by the, the right angle, all we did was connect the two pieces of the angle and we made a triangle, and that is now a right triangle. Pythagorean theorem only works on right triangles, okay? So if there's a question where it says find the length of this leg of a triangle and it's not a right triangle, can't use Pythagorean theorem. We have to use something else, okay? Now, pieces of the right triangle, this is very, very important. There are 3 pieces you have to know. The first 2 are called legs, okay? The legs are the shorter sides of the right triangle. The hypotenuse, have you guys heard that word before? Hypotenuse, okay? It's a weird word, hippopotamus kind of, hypotenuse. That's the longest side of the right triangle, and it's very, very important. The hypotenuse is always across from the right angle. So you see how the little square right here is in the corner? Whatever's across from that is the hypotenuse. It's always the longest side. Okay. So those are the 2 things you really have to know. The hypotenuse is always the longest side, and the hypotenuse is across from the right angle. So if I gave you a triangle and I said, which one is the hypotenuse, how would you be able to tell which one the hypotenuse is? The longest line, or It's the one across from the right angle. So could this side be the hypotenuse? No, because it's not across from a right angle. It's across from this. That's not a right angle. Could this side be the hypotenuse? No, because it's across from this, and that's not a right angle. The hypotenuse is always going to be the side across from the right angle. Okay? It's important because the triangle is not just going to always say, I'm the hypotenuse. Hey, morning, right? You have to know which one is the hypotenuse. And it's always the one across from the right angle. Okay? Now you're probably saying, well, why do I have to know which was in the hypotenuse? Why does it even matter? Because the Pythagorean theorem is very specific. Okay, very specific. The Pythagorean theorem says that if you have a right triangle, the sum of the squares on the legs are equal to the squares on the hypotenuse. Okay, now that sounds confusing, but in application, it's really not that bad. So the theorem itself, the formula we use is a squared plus b squared equals c squared. And that's why it's important to know A and B are always your legs. They're always going to be the shorter sides. C is always going to be the hypotenuse, always. Okay, that's why it's always important to know which one is the hypotenuse. A and B, you can mix up because they're just the legs. You can mix up A and B, that's fine. But C always has to be the hypotenuse, always. Okay. Now, if you look at the picture and you counted up all these squares, you'd be able to see. So if we look at the purple, there's 9 squares here. If we look at this kind of pink color right here, there's 16 squares here. And what's 16 plus 9? 25. Just yell it out, y'all. Okay, 25. Thank you, kiddos, in chat for responding. So it makes sense. 9 plus 16 is 25. And that's exactly what it says down here. The squares on the legs. So we have 9 squares here. We have 16 squares here. They equal the squares on C, which is 25. So it works. Okay. Now let's look at it, what it would look like if there weren't a picture here, if we just had some numbers. Okay. So does Pythagorean theorem really work? Here's kind of our first example. So we have a right triangle. And the first thing we have to think about is what is A, what is B, and what is C. So A and B are not locked into place. They can be interchangeable. What's the only letter that must be the hypotenuse? C has to be the hypotenuse always. So this side here must be C. How do we know again that this is the hypotenuse? There's 2 ways. It's across from the right angle. And what's the other way we know it's the hypotenuse? It's the longest side, right? 10 is longer than 6 or 8. So we know that it's the hypotenuse on those 2 reasons. It's across from the right angle and it's the longest side. Okay, so let's fill in the letters. Do you want 6 to be A or B? It doesn't matter. Let's go with A since you guys are short to answer. Okay, so that means this is B. Again, it doesn't matter which one you put as A, which one you put as B. Okay, so let's fill in our numbers. A squared would be 6 squared. Okay, plus B squared is now 8 squared equals C squared, which is 10 squared. Okay, let's see if you guys got this locked in without a calculator. Does anyone know what 6 squared is? 36, very good. Okay, plus 64 equals 100. Okay, if you add up 36 and 64, that's 100. It equals 100. And so Pythagorean theorem works. We just proved it. Not really. Okay, not a proof exactly, but it shows mathematically that it works out. That a squared plus b squared does equal c squared. Okay. Now, this is not really why we use Pythagorean theorem. Pythagorean theorem is used when we don't know one of the sides. So if it says like, find the missing side of the right triangle, that's what we use Pythagorean theorem for. Okay, so that's what we're going to do next. We have 3 examples where we're finding the missing side of the right triangle. Okay, so in each problem, either A, B, or C is going to be missing. And we have to figure out what A, B, or C is. So we're going to be using square roots. Okay, that's why we have our calculators out. Now on formative tonight for your homework, you're going to leave the answer in the square root, okay? To make your life easier. But I want you to understand how to put it in your calculator because you're going to need that for like your STAR testing, for your CASP, your junior year. You're really going to need to know how to use these calculators, okay? So let's get into it. Use the Pythagorean theorem to find the missing length. Okay, so again, we have a triangle. We have the legs given to us, and then we have C, which we don't know. So again, A and B are interchangeable, but I'm just going to go ahead. I'm going to say this is A and this is B. Is everyone okay with that? Okay, nods everywhere. Okay, so let's plug it in. Instead of A, what do I write? So 5 squared plus, instead of B, I write 12 squared equals, and then C squared we don't know, so we keep it C squared. Okay. 5 squared is 25. 12 squared, 144, equals C squared. Now at this point, if you don't know what 144 plus 25 is, you're going to switch over to your calculator and you're going to add those numbers up. 25 and 144 makes 169, and that equals C squared. Okay. Now I don't want C squared. I want C. So how do I get rid of the little square? Not times itself. We need to find C. So I need to get rid of this. This is what I need to get rid of. Yes. Do the square root. Okay. So if I want to get rid of the square, then I use a square root. That's what we talked about at the beginning of class. Okay. So if I square root one side, what do I have to do to the other side? I have to square root the other side as well. So at this point, you are going to stop here, and this is your answer. So you would put in formative that the answer is the square root of 169. Okay. But I want to show you what the actual answer would be if you put it into a calculator. Now, the reason we're avoiding doing the next step is because I don't want you guys to have to worry about decimals. But this problem isn't going to turn out to be a decimal. It's going to be a whole number. So we would go to our calculator and we would type in the square root, and then we do 169. We hit equals, and the answer would be 13. Okay. So on formative tonight, if you say that the answer is the square root of 169, that's great. If you say that the answer is 13, that's great as well. Either of those are correct. Okay. You can stop at the square root, or you can put it in a calculator and get the actual answer. Either way, I will mark it as correct. Okay. Now, does 13 make sense for the hypotenuse? What is true about the hypotenuse? What's the one thing we know about it? It has to be the longest side, right? Good. So is 13 longer than 5 and 12? So that makes sense, right? If we got 10, would that make sense? No. So because it's 13, that makes sense. That could be the answer. Okay. Let's try another one. Okay, we're going to switch it up a little bit. This next one, what letter is missing? What letter? Sorry, I didn't hear you guys. A. You see, A is the variable. Okay. So that means we're going to fill in the other letters. So again, just so we can see it, this is going to be B and this is C. Okay. So let's fill in our letters. Instead of A, we just keep it A squared. Morning. Okay. Instead of B, we write 24 squared. Okay. Instead of C, we have 25 squared. Okay. And now we got to square some numbers out. Now, this is what I was talking about when I said you might not know what these numbers are, so you're going to have to use a calculator. Okay. So A squared stays A squared plus 24 squared is 576. If you don't know, go to your calculator. 24, the square exponent button is right here. 576. Okay. 576. And then 25 squared is 625. Okay. Now, we need A squared by itself. We have to get A squared by itself. So that means I need to get rid of 576. How do I do that? I subtract. The opposite of plus 576 is minus 576. Okay, minus 576. Now, lucky for y'all, I've already done these calculations. But if you don't know, you can always use a calculator. That's going to give us 49. And then I have one more step. I don't want A squared. I want A. So what do I do to get rid of this little square? Square root. If I do it to one side, I have to do it to the other side. And so my final answer is either going to be the square root of 49, or if I put that in a calculator, the answer would be 7. Okay, so either of these answers is perfectly okay. Okay, so let's talk about the steps one more time. We fill in the letters and we square things out. We have to subtract the 576 because I want A by itself. After I get A by itself, I want the square to go away, so I take the square root, and I can either leave the answer in the square root or I can put it in a calculator and get the answer, which is 7. Either of these is fine. I personally would just stop here because then you don't have to do an extra step. Okay. Okay. Any questions? Okay, kiddos, we got one more example just like this. One more example. We're going to switch it up. We did one where A was missing, one where C was missing. So now let's do one where B is missing. Okay. So again, you fill in the letters that you know, and B is just going to stay B. So just so we have this clear, let's mark. A would be 5. Oh, let me switch back to a different color. Okay. And then tell me again, how do I know that this side is C? It's the longest side. And remember, C is called the hypotenuse. We also know because it's across from the right angle, right? So this has to be C. So let's fill in the letters. Instead of A, what letter or what number do I write? 5 squared, good. B is just going to stay B. And C is going to be 13 squared. Okay. Now let's square this out. 5 squared is 25. B squared just stays B squared. 13 squared is 169. Okay, again, calculator if you don't know. What would my next step be if I want to get B by itself? Yes. I need to get rid of the 25. So I'm going to subtract 25 from both sides. just like we subtracted on the last problem. Okay, that goes away. B squared is now by itself. 169 minus 25 is 144. Okay, and I got one more step. I want this little square to go away. How do I get rid of the square? Square root. If I do it on one side, I have to do it on the other side. So my final answer is either the square root of 144, or if I did want to find the answer, I could go to my calculator and I could type in square root 144, and the answer is going to be 12. Okay. Either of these is acceptable. They'll both be marked correct in formative. So pick which one you think is easier. I, again, would leave it in the square root just to save myself some work. Okay. So this, in essence, is Pythagorean theorem. Okay. So you're either plugging in numbers into the formula and then working backwards to solve for the missing letter, right? Or like our next example, you're going to have to think about where the numbers are lining up, and then you have to plug them into the formula based on a word problem. Okay, so we got a word problem coming up next. Okay, hopefully you'll be able to figure out everything based on the picture. Okay, so the foot of a ladder is placed 6 feet from a wall. If the top of the ladder rests 8 feet up the wall, how long is the ladder? So you can kind of see from the picture that we have a right triangle created, right? So this is the image that we're given. We know it's a right triangle because it's up against a wall, so these are straight lines. This side is 8, this side is 6, and we're looking for how long the ladder is, right? So if this was the ladder, we're looking for this. Okay. Does that make sense based on the picture? Okay. So we have to label these sides so that we can plug them into the Pythagorean theorem. So remember, the Pythagorean theorem says a squared plus b squared equals c squared. Okay, so let's plug things in. What do you want 8 to be? What letter? A. Good. You guys are making decisions. What about 6? B. Do A and B matter? Can we flip-flop those? Yeah, that's fine. A and B you can switch. It's fine. What's the one that has to be C? Say the word. What's it called? Starts with an H. Hypotenuse. Good. We're getting used to the vocab. Okay. And that always has to be the side across from the right angle, right? So this has to be C, the thing we don't know. Okay. So A is going to be 8 squared. B is going to be 6 squared. And C squared, we're just going to keep C squared. Okay. So this should look very familiar. We've done an example just like this, but without the word problem part. So now this part should be easy. What do we do with 8 squared? What is that? 64. Okay. And then 6 squared is 36. Very good. And that equals C squared. 64 plus 36 again gives us 100. And that equals C squared. Now I don't want C squared. I want C. So how do I get rid of the square? Square root. Okay. Bye-bye. Now, 2 possible answers. You can either keep the answer as square root of 100, or off the top of your head, anyone know what the square root of 100 is? 10. Very good. Either of these answers is perfectly acceptable. Okay. Easy peasy lemon squeezy. And that's Pythagorean theorem. Okay. So on Wednesday this week, right, we'll be having a review. It will not be a quiz. Okay. I want to give you more time to work with Pythagorean theorem before I give you a quiz on it. So we will have a review in class on Wednesday, not a quiz. And then we'll move forward with new material on Thursday. Test coming up next week. So make sure that you're staying on top of these dates.